that 318?
It doesn't really matter what they are. It's 2, 3, 7, 5, negative 4, negative 2, 3, 1, 8. And when I write out the matrix, okay? Now, I'm not going to write out all the steps that connect this to the matrix, right? But the steps are going to be identical to the steps I did there. And I'm going to skip kind of the augmented matrix, just go directly to the matrix, because if you have a square, if you're going to get a square matrix, which becomes pretty clear about the time you write down your system of equations, I hope, okay? The same process would yield this equation as your test, right? So how will you solve this? Well, the easiest way to solve it is multiply both sides by the inverse matrix. Might not be the easiest, but invert the matrix, okay? Well, you don't actually have to invert the matrix to see that if you can invert the matrix, which is not guaranteed, then you're going to get 0, 0, 0, right? So this works if the matrix is invertible. So that C1, C2, C3 would be the inverse matrix times the 0 column, which gives you the 0 column, right? Meaning that C1, C2, and C3 are all 0. Okay? So the set is linearly independent. Okay? Now there's an if. How do you test the if? Do you invert the matrix? You could. You could try to invert it.
Could you also just check the determinant?
I'm sorry?
Did you check the determinant?
Yeah. That's the easiest thing to do, right?
Yeah.
Unless the matrix looks like it's real easy to reduce. You know, you reduce it and end up with a row of zeros, that'll do it. They'll show you can't invert it, right? And you don't even have to build up the inverse then.
Mm-hmm.
Okay? Matrix is invertible if and only if its determinant is non-zero. Okay? So if determinant not equal to 0, the set is linearly independent. Okay? Now that doesn't prove that if the determinant is 0, the set isn't linearly independent. Okay, so let's consider what if the determinant equals 0. Well, that would mean that the matrix would reduce down to a matrix with a row of zeros. okay? And I'll just indicate that form with okay? Some form with a row of zeros. Now you might have a 1 here, and a 0 here, and a 0 here, and a 1 here. Okay? It might come down to that, but you know, these could be anything, 0 or not. But if you get a row of zeros, that implies you got a free variable. So not all the C's will be 0. Okay? Now actually, it looks more like this, right? The augmented matrix, and it's really kind of this. It implies that you got a free variable. That makes it obvious that there's a free variable, especially if you write out the equations, right? Okay? So if the determinant isn't 0, you're going to be able to reduce it down to something that has a row or column of zeros. Okay? Which, in the form of the augmented matrix, tells you it's not going to pass a test for linear independence. Okay.